This video is over lesson 87, factoring polynomials by grouping, and it is for my Algebra 1 class. So, ladies and gentlemen, just a quick review before we dive into this new concept. We've done factoring polynomials in a few different ways already, and so I want to explore a few of those here real quick just as review. So remember that we've looked at factoring special polynomials, particularly perfect square trinomials. So if we find something in the form of a squared plus 2ab plus b squared, then we know we can factor that as a perfect square. So the key here is to look, is our first term the square of something? Is our last term the square of something? And then is the middle term double the product of those two somethings? So in this case, sure it is. This is x squared, this is 5 squared, and so their product would be 5x. Well, 10x is double that. So that means that this can be factored then into x plus 5, those are my two somethings, squared. Over here we see the other special product that we've learned about, which is the difference of squares. And so we're looking for something squared minus something squared. So this is x squared, obviously. This is 5 squared. And so when we have a difference of squares, we can split this up, remember, into a product of conjugates. So conjugates being two binomials where one's addition, one's subtraction. Otherwise, they're identical. We've also taken a look at factoring trinomials in general. So of the form x squared plus bx plus c. And so remember, the key idea here is we usually start with c just because it's easier. And so we ask ourselves, what times what would be 24? So what times what would be c? And then those same two numbers have to add together to make b. Now you could start with b and then try to find c, but it's just typically easier. Usually we have less factors than we do add-ins. So what times what would be 24? That when I add them together would be 10. Well, x plus 4 and x plus 6. Sorry, I got a little bit of a glare there on my board. There we go. And then we've also learned about factoring trinomials when they aren't nice and neat with a 1 leading coefficient. So what if they have some other leading coefficient? Like in this case, a 6. Well, in this case, we need to consider what times what could be a and what times what could be c. And then we have to think through our FOIL. Is there a way to take these leaders and these enders and put them together in such a way that if we were to FOIL it, we'd get 26 for that middle term. One thing that really helps in general when it comes to factoring, though, that we really want to do, this is kind of like step 0 of any time you're factoring, is consider, can you factor something out of the entire polynomial? Like in this case, I noticed that 6, 26, and 24 are all even, and so we could factor out a 2. And so this would be 3x squared plus 13x plus 12. And that actually makes this a lot easier, at least a little bit easier. Because before 6 could have been 1 times 6, it could have been 2 times 3. But now that I factored out the 2, since 3 is prime, there's really only one option here, that we're going to have a 3x and we're going to have a 1x, or just x. And so from here, it's just a matter of now thinking through, okay, what times what could be 12? And then can we get this in such a way that if we were to FOIL it, we'd get 13 in the middle there. So when I consider that, maybe I come up with, try out 4 here and 3 here. And now if I were to FOIL this, 3x times x would give me my 3x squared. 3x times 3 would give me 9x. 4 times x would give me 4x, so 9x plus 4x, sure enough, gives me that 13x. And then 4 times 3 would give me my constant 12. So In review here, ladies and gentlemen, I really want to emphasize the point that it is very helpful, very important that you look and see in each of your terms, is there something you can factor out right away? That will make our problems easier in the long run. So, going back now to what we have for today, we're going to learn a new method that works when we have 4 terms. So when it's got an extra term, it's not just a trinomial anymore. So we're going to start with 2x squared plus 4xy plus 7xy. Oh, sorry, it's just 7x. 7x plus 14y. And so for this method, what we're looking for is we want to start by grouping terms. So we're going to group terms with a common factor. Now, sometimes when we look at the problem, this is just going to be something we conceptually do. We're going to be all set to go. We won't have to do anything else. Sometimes this will mean we need to rewrite the problem. In this case, we actually could be just all set to go. So when I look here, I look at my first 2 terms, and I see that they both are divisible by 2, and they both have an x in them. When I look over here, I notice they both have a 7 that can factor out of these. So let's try that. And I will warn you ahead of time that this can sometimes just be a little bit of guess and check, where sometimes we'll try something out and discover it works. Sometimes we'll try something out and have to go back to the drawing board. But that's the reality of higher mathematics, is that it doesn't always work out neatly. Sometimes you've got to play around with these skills. Sometimes you got to see if this skill will work here or if it will work there. Sometimes it does, sometimes it doesn't. So we're going to try it out here. I'm going to group these 2 together then. So again, notice the red pen there. We don't actually have to write parentheses in our work. And then I'm going to group these 2 together. So now I'm going to go ahead and I'm going to factor out what I can from here. So I can factor out a 2x from there. Left behind would be an x and plus 2y. Then in my second pairing, I'm just going to factor out the 7. So if I factor out the 7, I'll be left with an x and a 2y. And so what we discover here is what we want to find. We want to find a quantity left over here that is the same in each of these. Remember that multiplication and parentheses group things as one term. So technically we have 2 terms here. So we've got this, so the 2x with the quantity and the 7 with the quantity are my 2 terms. So when I look at that, I see the quantity the same. So my next step, I'm going to factor out the GCF of each group or each term. So that means that I'm definitely going to take the quantity out, but we do also want to see between the 2x and the 7, is there something else we can factor out of here? This time, no, but it's worth giving it a look. Okay, so real quick, grab your yellow before we move on too fast. But this, when we're using this skill, this is what we want to discover. We want to discover a quantity that is the same in each of those groups or each of those terms. So now, if I pull the x plus 2y out of each of these, then what's left behind will be another quantity. So what's left behind here then is my 2x, and what's left behind here will be that 7. And ladies and gentlemen, we have now managed to factor this into 2 binomials. So just to put a little note here, the GCF there was the x plus 2y. Now, we should always double check our work, make sure that it works out correctly. So to check our work, we're going to take our factored expression and FOIL it. So to check, FOIL. So x times 2x gives me a 2x squared. That's my first. Now my outsides, x times 7 is 7x. My insides, 2y times 2x is going to be 4xy. And then my last, 2y times 7 is 14y. Now this isn't exactly that. However, quick little commutative property of addition, and it's exactly that. So I don't really need to show that commutative property. So at this point I would just check, say yep, it checks out. So ladies and gentlemen, we're going to practice this a few more times here. So our next example will be 3y squared minus 8y cubed minus 8y and then plus 3. So for this one, I hope what catches my eye catches your eye. I notice 3 and 3. I notice 8 and 8. I'm going to want to put those together. That just looks good to me. I'm going to start with my 3y squared and then a plus 3. And then I'm doing that first, even though this won't be standard form, just because if I put my minuses next, my negatives next, I can write them as minus signs. So now obviously these two group together and these two group together. So I can definitely pull a 3 out of these first two terms, and that's actually all I can pull out. So this will be a y squared. And then remember, if you pull a 3 out of a 3, if we were to distribute back in, 3 times what would give you that 3? 1. So very common error early on in algebra and pre-algebra when students are first learning distributive property. If they factor a number out of itself, they often just have it disappear. Remember, that's incorrect. If it factors out of itself, it's a 1 left behind. All right, over here, obviously I can pull an 8 out, but also since these are both minus 8s, I'm going to factor out a minus 8. And then I notice that each of these has a y, so I'm going to pull out a y as well. Now, I'm going to pull out a negative 8y, so the negative is gone, the 8 is gone, and one of the y's is gone, so that's y squared. And then for this other one, the negative is gone, the 8 is gone, and the y is gone, which means if everything's gone, it's a 1 left over. And again, ladies and gentlemen, we find exactly what we hope to find here, that we have the common quantity y squared plus 1 in both of these, which means now I can factor out that y squared plus 1. And then what will be left over here will be a 3. What will be left over here will be a minus 8y. And we have factored our polynomial. All right, next example here. Let's take a look at 45a cubed b, and then minus 15a cubed plus 15a squared b minus 5a squared. So looking at this guy, there's a few different ways that we could end up doing this one. In particular, I kind of like the fact that this has a b and that has a b. So I might choose to rearrange this one a little bit. We could try to just go with it the way it's written, but I kind of like the idea of rearranging this a little bit. So 45a cubed b. I'm going to slide the other one that has a b in it next to it, because then I can factor that b out of both of those. What will be left over here will be a minus 15a cubed minus 5a squared. And now if we factor, so out of both of these I can pull a 15, I can pull an a squared, and I can pull a b. And so then what will be left over will be a 3, and then just a single a. We're pulling 15a squared b out of itself, so this will be a plus 1. So we're hoping on the other side here to see a 3a plus 1. So I'm going to pull out a negative 5a squared from both of these. They're both negative. They both are divisible by 5, and then they got at least 2 a's in there. So if I pull out a negative 5a squared, it'll just be a 3a left over. Pull out a negative 5a squared, that's the whole thing. So plus 1 is left behind. So sure enough, we found exactly what we were hoping to find. So now I'm going to go ahead and factor out the GCF. So ladies and gentlemen, if you take a look here, remember that the GCF isn't just going to be the quantity. Is there anything on the outside that we can pull out as well? So looking at this, I've got a 15 and I got a 5. I'm going to pull a 5 out as well. And then I notice that there's an a squared here and an a squared there. I'm going to pull an a squared out. And so then I pull my quantity, 3a plus 1. And let's consider what's left over now. So in this first term, we pulled a 5 out, so that means 3 is left over. We pulled an a squared out, so the a's are gone, but we still have a b. And then we pulled the quantity out. So that's all that's left from this first term. In the second term, we pulled a 5 out, so the negative is still there, but the 5 is gone. We pulled an a squared out, so that's gone. And we pulled a 3a plus 1, so that's gone. So there's nothing left there except for the minus and a 1. And ladies and gentlemen, we've just managed to factor that completely. Now, a quick double check. Maybe you forgot to check the outside of these guys. And if you did that, then you're going to find that this binomial that's left over will have something that can factor out of it, and then you'll have to do that. So if I go back just one step here, so 15a squared b times 3a plus 1 minus 5a squared times 3a plus 1. So we just go back to that step. So let's say we didn't catch the GCF there, we just pulled out the quantity. Then it'd be a 15a squared b left over there minus a 5a squared left over here. And so this is what I was talking about. We see that, oh, I can factor this binomial more. So we do that. So 5 goes into both of those. An a squared can come out of both of those, and that's it. So now I've got my 3a plus 1. And then when I pull a 5a squared out of this, we have a 3b left over minus 1. So if you don't catch that, it just adds an extra step in it, as long as you remember to check your binomials. Can we factor these binomials any further? All right, we're going to go back and do this problem again. I just want to show you a little bit of the flexibility that you have here. So this time, let's just go ahead and go for it the way it's written. So I'm going to put these two terms together. I'm going to put those two terms together. So pulling out of these two terms, notice that we can pull a 15 out of both 45 and 15. We can pull an a cubed out of both of these, and that's it. So left behind would be a 3b, and then minus 1. For my next one, I'm going to pull a 15 and 5. I'm going to pull a 5 out of both. And then I can also pull an a squared. So what's left over, if I pull a 5a squared out of that, would be 3b. If I pull a 5a squared out of that, it'll be a minus 1. So notice the difference that this made. So whereas up here, the quantity that we ended up was 3a plus 1, down here, by doing it this way, I just end up with the quantity 3b minus 1. So there is some flexibility here in how we do it. So now we go ahead and look for the GCF. Now don't, remember, make your life easier. Don't just pull out the quantity. Take a look at this guy, take a look at that guy. So with a 15 and a 5, I can pull a 5 out of both of those. With an a cubed and an a squared, I can pull an a squared out of both of those. So, and then of course I'll pull up my 3b minus 1. So left behind, if I pull out the 5, the a squared, and the quantity, will be a 3a. And then over here, if I pull out a 5, an a squared, and my quantity, well, that's all of it, so it'll be a plus 1. And so you'll notice in comparing these two answers, using the commutative property of multiplication, they're really the same answer. All right, ladies and gentlemen, well, if you hadn't had enough of this problem, you're about to. We're going to do it one more time. And I promise this will be the last time. So take a look at it one more time. Let's see, minus 15a cubed plus 15a squared b minus 5a squared. This time, we're going to do what I suggested to do at the beginning of this video. I don't know how many of you watching the video have been sitting there and thinking, but Mr. Burford, you said, and I know what I said, and I'm wondering how many of you remembered. But in case you forgot, remember you can make your life easier by looking at each of these terms to start with and just saying, is there something we can pull out of each of them? So with a 45, a 15, and a 5, we can pull a 5 out of each of these. With an a cubed, an a cubed, an a squared, and an a squared, I can pull an a squared out of each of these. This has a b, this does not, which means that we can't pull b's out of each of those. So 5a squared is the greatest common factor of each of these, all 4 of these together. So before we've been doing these in pairs where we pull the greatest common factor out of each pair, but this time we're just pulling them out of the whole thing. So left behind now would be a 9ab minus 3a plus 3b minus 1. And so if we go ahead and factor that, I see a 3a here and a 3a there. I'm just going to go for it. So 5a squared. And then over here, if I pull a, you know what, we got a lot of parentheses going on. So let's just make this a little clearer here. Let's make this, turn these outside guys into brackets for right now. So, so I'm going to pull a 3a out of these both. So 3a will leave a 3b left over. And then this will be a minus 1. And then over here, there's nothing that I can really pull out of each of those. So what I'm going to do is I'm just going to group them together as a term, as a quantity. Because what I'm looking for is I'm looking for that to match. Now remember, ladies and gentlemen, there is always a coefficient. So in this case, it may not be written in, but it really is an invisible 1 there. So when I go to finish this off, I'll have my 5a squared, and I'm going to pull a 3b minus 1 out of each of these. So 3b minus 1 out of each. And then what's left over? Well, 3a plus 1. And again, we notice the same answer. So ladies and gentlemen, you've got a lot of different ways that you could do these. There's a lot of variation in how they can be solved. whether you do this or do that, how you group them together. But as long as you follow the basic steps of grouping things together that have a common factor, factoring out the GCF, and then um, factoring out the GCF again, of the new terms, you should be able to find it. When in doubt, double check your answer by foiling whatever you get. And ladies and gentlemen, if you are struggling with this at all, please make sure to contact me and ask me questions. But that is the end of our lesson.